The last thing that we need to review before jumping into solving exponential and logarithmic equations is properties of logarithms. So on page 3, we're going to review both minor properties of logarithms and major properties of logarithms. We're going to start at the top of page 3 with the minor properties. You can see that I have them broken down by base, but keep in mind that these properties of logarithms apply no matter what the base is. All right, we're going to start with base 10. Remember, with base 10, you're simply going to see log. The subscript is usually omitted, but you can remind yourself that log means base 10. So the first property here is, what is the log of 1? Okay, this is something that you can pop into your calculator, but it's really good to know what this is off the top of your head. So how would we figure this out without a calculator? Well, we would first remind ourselves that this is a base 10 logarithm, and then we need to apply the arrow definition. So if I take 10, what power do I need to raise it to get 1? So 10 to what power gives me 1? Well, we know that anything to the 0 power is 1. So the answer to the logarithm is 0. Okay, we can confirm this on a calculator. The log of 1 is 0. Okay, moving on. What is the log of 10? Okay, again, you could pop this into the calculator or do it by hand. If you see log, this is base 10. 10 to what power gives you 10? Okay, so the only way these two sides of the equation can match is if this is the first power. 10 to the first power gives you 10. So the log of 10 is equal to 1. Okay, log of 10 is equal to 1. Okay, now we get into an expression with a variable. Okay, so I have log of 10 to the x. What is that simplified to be? Okay, you can still simplify this even though we have a variable here. It's going to work the same way. The base is 10. 10 to what power gives you 10 to the x? Okay, 10 to what power gives you 10 to the x? The only way the two sides can match is if x goes in the blank. Okay, so the log of 10 to the x is just x. Okay, as an example, you could put numbers in this. Okay, so if I said, what is the log of 10 to the 7th? Okay, the answer is just going to be 7. Okay, remember, we talked about the fact that log base 10 of x and 10 to the x are inverse functions. So if you see them side by side like you do here, the log of 10, they're next to each other, there's nothing in between them, they cancel out, and then that exponent's going to come down as the answer. Okay, so log base 10 of 10 to the x is just going to be x. Okay, the last base 10 property here, kind of the same thing, but the reverse order. If I have 10 raised to the log of x power, okay, this one's a little trickier to think about, but remember what I just told you. 10 and log are side by side, so they're going to cancel out, and the answer is just going to be x. Okay, now keep in mind, if I had something separating them, so maybe if I had 10 raised to the 3 times log x power, they would not cancel. They have, the 10 and the log have to be side by side. Okay, so as an example here, if I had 10 raised to the log of 4 power, okay, the 10 and the log would cancel out. The 4 would come down to be the answer. Okay, all right, so we're going to repeat these properties. They're basically the same thing, but now we're going to use a natural log instead of a common logarithm. Okay, so base e, we know that means ln, or natural log. So here it would work the same way. If I see the natural log of 1, that means base e. What power do I need to raise e to get 1? Okay, and we know that anything to the 0 power will give you 1. So e to the 0 power is 1. So the answer to the logarithm is 0. Okay, again, natural log of 1 gives you 0. Okay, in the next property, okay, natural log of e is what? Okay, You really want to remember this. This comes up quite a bit. Okay, but again, to work this out, we know we're dealing with base e. If I take the base, what power do I need to raise it to get e? E to what power gives me e? These guys match as long as one goes in the blank. Okay, e to the first power is e, so the answer to the logarithm is 1. Okay, you can punch this in to verify that the natural log of e is indeed 1. Okay, so now what happens if we have the natural log of e to the x? Okay, same thing. E is my base. What do I need to raise e to get the quantity e to the x? Okay, these two sides of the equation can only match if x goes in the blank here. Okay, so the natural log of e to the x is x. It's the same kind of thing. Natural log of x and e to the x are inverse functions. So if natural log and e are side by side, they are going to cancel out. So as an example here, if I had the natural log of e to the -1, okay, the natural log and the e would cancel out and the -1 would come down as the power. You can verify that on a calculator. The natural log of e to the -1 power, that's going to give me -1. Okay, the last base e property is the same thing, but just kind of in reverse order. This is another property you will see a lot in calculus. E raised to the natural log of x power. Okay, this is a little more difficult to reason through, but when you see it, the e and the ln are side by side, so they're going to cancel out, and you're going to be left with x. Okay, so these two guys would cancel, you'd be left with x. As an example, okay, if you see e raised to the natural log of 1,000, okay, the e in the natural log would cancel, and so the 1,000 would come down as the answer. Okay, all right, so we've done these properties for base 10, we've done them for base e. They apply in general, okay, so they apply for base a. Okay, so I'll do another set. They're essentially the same, but I'll write them down for base a. Okay, remember, any positive number other than 1 can be the base. All right, so this a could be base 4, base 7, base 10, or sorry, base 8, whatever. Okay, what's the log base a of 1? Okay, well, again, if I take the base a, what power do I need to raise it to get 1? A to what power gives you 1? A to what power gives you 1? Okay, it's just like what we saw when we computed the log of 1 or the natural log of 1. Okay, anything to the 0 power is going to give you 1. So a to the 0 power is 1, so the answer to the logarithm is 0. Okay, so from this first property, whether if we're looking at it from base 10, base e, or a base a perspective, the logarithm of 1 is always 0. Okay, moving on to the second property. What's the log base a of a? Okay, so if I take the base here, a, what power do I need to raise it to get a itself? Okay, a to what power gives you a? Well, it has to be the first power. Okay, so that's going to be 1. Okay, log base a of a is 1. And, you know, if we had a specific base on it, like log base 10 or natural log of e, those guys are going to equal 1 for the same reason. Okay, all right, so when we did this with base 10 for the next property, we said log of 10 to the x was x, and natural log of e to the x was x, because if you have the exponential function and the logarithmic function and they're side by side, they end up canceling out. So here, if you have log base a of a to the x, you have log base a and a side by side, so they end up canceling, and the answer is going to be x here. Okay, you could do the arrow thing on it. Okay, a to the x power has to equal a to the x. Okay, those two sides have to equal. Okay, so as an example of this particular property, if I asked you what the log base 14 of 14 equals, okay, see how the subscript, the base of the logarithm, equals the exponential part, and let me put an X on here. So the base of the logarithm equals the exponential base, okay? So the log base 14 and 14 would cancel. That would leave you with X here, okay? If I put something in for the X, okay, it would also work here. If I had log base 14 of 14 to the 9th power, the log base 14 and 14 would cancel, and the answer would be 9, okay? All right, last property here, along the same lines, if you have a raised to the log base a of x, again, you have a situation where a is side by side with log base a. Those guys are going to cancel. The exponent is going to come down as the answer. All right, so if I had, let's see here, let's do, I don't know, let's do 9 raised to the log base 9 of 22. Okay, the log base 9, it's side by side with the 9. They will cancel, okay, and then the 22 would come down and be the answer, okay. If you had 9 raised to the log base 8 of 22, there's going to be no cancellation here because you have 9 but log base 8, okay. The bases do not match, and so you couldn't cancel here. Okay, the answer is going to be more complicated than 22. Okay, so keep in mind these properties hold if you're dealing with matching bases on the exponential and logarithmic sides. All right, so these were the minor properties of logarithms. Now we're going to take a look at the major properties of logarithms.